Welcome back. In this video, we are looking at section 1.3. This section is multiplying and dividing fractions. To multiply fractions, multiply the numerators and multiply the denominators. The result of multiplying two fractions is called their product. If a over b and c over d are fractions, then a over b times c over d equals a times c over b times d. When we are looking at multiplying, we saw that the numerators are going to be multiplied together and the denominators are going to be multiplied together. And so what I find helpful for me is to look and see if anything can be simplified or reduced before multiplying, because it's a lot easier to simplify using smaller numbers than it is with one larger number. And you can use your prime factorization to help with that, or you can think of multiples if you're good with your multiplication facts. And so let's look at some examples. For our first question, we have 12 over 7 times 3 over 11. And so first thing I do is to look and see if I can see any multiples, any things in common. I already said with this question, notice the denominator has 7 and 11. They are both prime numbers, which means that there's nothing that can simplify into them. 7 can only be 7 times 1, and 11 can only be 11 times 1. And so when we compare those numbers with the top, neither the 12 nor the 3 are either multiples of 7 or multiples of 11. What this means is that there's nothing that I can be able to do to simplify my problem. So when I multiply, what I get will be my answer. And so for 12 times 3 for our numerator, we are going to get 36. And then for our denominator, we're going to have 7 times 11, which is 77. So that's the final answer. There's nothing that can divide into both 36 and 77 to be able to simplify. Notice question B now has mixed numbers. In order to multiply using mixed numbers, we first have to change them into improper fractions. So we can do top times top and bottom times bottom as well. And so our first problem has 4 as the denominator and 2 as our whole number. And so we're going to multiply 4 times 2 to get 8, and then add that 1 onto it to get 9. So 2 1/4 is the same as 9/4. And then we have 3 and 1 9. So let's do the same thing. 9 times 3 is 27, plus 1 gives us 28. So that's going to be 28 over 9. Now I see that my 9s will be able to cancel because I have a 9 on the top and a 9 on the bottom. So as long as we're being able to go from the top to the bottom, we'll be able to simplify. And then I also notice that 4 and 28 are both multiples of 4 because 28 is 4 times 7. So instead of breaking it all the way down to the prime factorization, I'm just going to leave a 9 alone instead of changing it to 3 times 3. And a 28, I'm going to change to 4 times 7 because I know I have a 4 that's going to cancel with that 4 in the denominator. So I'm going to leave 4 and 9 alone in the denominator. And again, we can cancel the 9 with the 9, and we can cancel the 4 with the 4. All we have left on the top is the 7, and notice everything is gone on the bottom. So we mentioned before that anything times 1 stays the same. So there's technically an invisible 1 down there that we can write. And then this can be simplified even further because anything divided by 1 stays the same. So when we have some number over 1, our answer is just the numerator because 1 goes into 7 times. So this answer is a whole number. Our third example here has the whole number 3 times the fraction 21 over 6. And so to set this up, I want to turn my whole number into a fraction, so I can do numerator times numerator over denominator times denominator. And as we just dealt with in question B, with that 1, any whole number can be written over 1. And so I'm going to change 3 into 3 over 1. So I can see clearly that the 3 is going to be with the 21 in the numerator and 1 times 6 for the denominator. Also note that 3 can go into 6 evenly because 6 is the same as 3 times 2. So when we multiply, we'll just leave our 21 alone. 3 times 21 over, we have our 1, and are going to change our 6 into 2 times 3. So that way we can cancel out our 3's. And we are left with the 21 on the top and 1 times 2, which is 2 on the bottom. So when we multiply there, we get 21 over 2, which you can leave that as your final answer. If you prefer to write it as a mixed number, you can also say 2 goes into 21 10 times with 1 left over, so you can write it as 10 and a half as well. But 21 over 2 is a good answer. Now, to divide fractions, there's one thing that we need to do that's extra, and that is to turn the second fraction into its reciprocal and multiply as previous. The reciprocal means to take the numerator and turn it into the denominator, and the denominator into the numerator. So you flip it around. And the results of dividing two fractions is called the quotient. When we divide, the answer is always the quotient. And so here it shows us that if we have a over b and c over d for our fractions, then a over b divided by c over d is equal to the same thing as a over b times d over c. So notice how it flips. And so we get a times d over b times c. Now I just want to take a second and show you that this is going to be true. Because sometimes we're told a rule without quite understanding why. So I'm going to pick two fractions that actually can divide top and bottom. So let's take 21 over 55 and divide it by 3/5. So it is very rare that you would have a problem set up like this where you can actually divide across. But in this case, we had 21 divided by 3 gives us 7. And 55 divided by 5 is 11. So the answer to the problem is 7 over 11. And you can see that because it comes out evenly. But let's use the rule that we just learned and flip the second fraction to multiply. So we'll have 21 over 55 times, flip it and make it 5 over 3. And so again, now I'm going to look with my numerators and my denominators and see what, if anything, is in common. So first thing I see is that 5 and 55 are both multiples of 5. Then also, if you divide 21 by 3, you're going to get 7. So 21 is a multiple of 3 as well. So let's write our 21 as 3 times 7. And then we have our times 5 from the second fraction. And let's turn 55 into 5 times 11. And then we have times our 3 from the second fraction. So let's start canceling like terms. Our 3 cancels with our 3 from the bottom, and our 5 cancels with our 5 on the bottom. And so what we have left is only the 7 on the top and only the 11 on the bottom. So notice we get the same answer. So again, you're not going to be able to divide straight across like we did in this example, but it shows you how when we flip and multiply, it does work. It does give you the answer, and that's why we have to take the reciprocal of the second fraction and flip it. So let's look at a couple more examples. So again, it's reminding us in the directions to reduce to lowest terms, and it's always helpful to reduce first if possible, because then we're dealing with small numbers at the end. So first thing we need to do is notice that there's a division sign. So we'll flip it because again, 18 divided by 21 would not come out evenly, or 10 divided by 16. So we will rename the problem to 18 over 10 times 16 over 21. Okay. So for this problem, I see that we can simplify a little bit with some even numbers in here. And so I'm not going to say it's going to give us the final reduced answer, but what I want to do is to take my 18 and turn it into a multiple of 3, because 21 is a multiple of 3. So that's one thing that I notice, is that 3 can go into 18 and 21 evenly. So I'm going to make 18 3 times 6 for my top. I'm going to make 21 as 3 times 7. And another thing that I see is that both 10 and 16 are even. And so I'm going to make those multiples of 2. So 16 is 2 times 8, and 10 is 2 times 5. Again, so there might be some more simplifying that needs to be done, but that's what I see easily. So that's where I'm going to start. And so the 3's can cancel that we created, and the 2's can cancel that we created. And let's see what we have left on top. We have 6 times 8, which is 48, and 5 times 7 to give us 35. 5 and 7 are both prime numbers, and if you look at 6 and 8, neither one of them have anything in common with 5 and 7. So that is as far as we can simplify. So 48 over 35, or if you want to write it as 1 and 13/15, you can as well. Just like in multiplication, we also have to change our improper fractions to mixed numbers when we're dividing. Because again, what we're really doing is flipping the second fraction to turn it into a multiplication problem. So let's do 4 times 4 is 16, plus 3 is 19, and that's over 4. And since we have to flip the second one, our 2 now will go on the top, and what goes on the bottom is 2 times 1, which is 2, plus 1 more, which is 3. So when we look at simplifying, 19 is prime. It can't break down any further. And 2 is prime, and it can't break down any further. But when we look at the denominator, 4, we know that that's 2 times 2, so let's write it that way since there's a 2 on the top. And then we have our 3 from our second fraction. So the only thing we can simplify is to divide out a 2. And when we multiply that together, we get 19 times 1, if you want to think of it that way, or just 19 on the top, with 2 times 3, or 6 on the bottom. So 19/6 is the answer, or 3 1/6. And for C, just like we did with multiplication, let's change 10 into a fraction by putting it as 10 over 1. And then we'll flip and make the problem 5/8 multiplied by 1 over 10. 5 and 1 in the numerator cannot be broken down any further, so we'll leave it as 5 times 1. 8 can be broken down to 2 times 4, actually 2 times 2 times 2, but there's no even numbers on the top, so no multiples of 2, so that doesn't help us any, so I'm going to leave it as 8. But 10 is a multiple of 5, so we're going to change that to 2 times 5. And so our 5 from the top can cancel with a 5 on the bottom, and we're left with only that 1 on the top, and 8 times 2, or 16 on the bottom. And so 1/16 is the answer there. So now that I've given you some examples, it's time for you to practice them. And if you get stuck on anything, please don't hesitate to send me an email, and I'd be more than happy to help you. Otherwise, I'll see you next time.